Dear friends, welcome back. Now we will discuss how to get the solution for parabolic equations. Already we discussed how to find solutions for uh, Laplace equation. This is the second kind, parabolic equation. Two methods are there to analyze it. In this video, I will explain in detail about Bender-Schmidt method. Repeatedly occurring equation in parabolic kind, it is one-dimensional heat equation. Can be written as first derivative with respect to u, first derivative of u with respect to t is equivalent to alpha square. Second derivative of u with respect to x. Here, alpha square equivalent to k divided by rho into c. Alpha square, which is equivalent to k divided by rho into c. What do you remember? It is heat equation. Then what about k, rho, and the c represents? They will ask for MCQs. Alpha square. In one-dimensional heat equation, alpha square represents k by rho into c. It is density, specific heat, thermal conductivity of the material. Density rho, specific heat k, and the thermal conductivity of the material. This one only alpha square represented here. Right. This is an example for parabolic equation. You can ask how it is. I will tell you. Here, setting alpha square equivalent to 1 by a, alpha square equal to 1 by a, for a convenient, we are going to take this. Then, if I'm giving like that, it will be this equation will be reduced to this second derivative of u with respect to x minus a into alpha square is 1 by a, and we are taking this side. Dou e by dou t equal to 0. Now, a value here it is 1, b value it is 0, c value it is 0. Find the discriminant b square minus 4ac, the value will be 0. If it is 0, you know very well it is under parabolic triangle. Am I right? Right. Now, I'm going to explain the Bender-Smith concept. Our aim is to solve the one-dimensional heat equation. One-dimensional heat equation is nothing but parabolic equation only. So, we are going to replace the derivatives to different quotients. This is what the one-dimensional heat equation they will give like that, or it can be also written as if they're taking to the right hand side, it will be u double x equivalent to a into root t, or this equation. This one they can be written as u double x minus a into ut equal to 0. So before to solve the Bender-Smith method, it's better to write this problem like that. Take to the right hand side, then choose your a. If it is left hand side, you will confuse whether you have to choose minus a or not. So that's why while you're solving Bender-Smith method, try to write the equation always like u double x equivalent to a into ut. U double x one side, ut another side after equivalent. It's better to write like this and then choose your a. Then only you won't do any mistakes. Right. With boundary condition, u of 0 comma t equivalent to one temperature because it's one dimensional heat equation. Would you remember? We solved in the previous semester. A rod of length L kept at temperature T1, here T0, here it is T1 until get the steady state condition. Suddenly the both end they will decrease to 0 or one end they will increase, decrease that and you discussed it in the previous semester. There we solved everything analytically. Now we are going to solve numerically. That is a major difference here. Right. This is boundary condition and the initial condition will be u of x comma 0 equal to f of x. So using this, we are going to discuss how to solve it. Right. Now we have to replace this equation by different portions. Second derivative, apply the second derivative on the first derivative of t. Second derivative of x will be this. First derivative of t will be this. Here important thing is x direction difference is h, y direction difference is k. I mean y direction means here it is t. T direction is k. Right. Then these are all the difference questions for the derivatives substituted here. Then if you're simplifying the derivation they won't ask just For understanding purpose only, I have given how to derive it. So you will get this equation. Here lambda square represents, instead of the lambda k by ah square, we have written lambda equal to k divided by ah square. Then the above equation can be written as ui comma j equivalent to this. In that way, you can write. Take this as equation 2. In MCQ, they will ask this equation. This equation is going to call explicit formula for parabolic equation. A Bender-Schmidt explicit formula. It is valid only if 0 less than lambda less than or equal to 1 by 2, excluding 0, including 1 by 2. Between this value of lambda only, it will valid. Valid means what? It will converge. You will get the solution, or else it may oscillate. That's what the meaning for it is valid, right? So for a particular value, if you're taking lambda equal to 1 by 2, then the substitute in the previous equation. What is the here? Replace lambda by 1 by 2. What will happen? 1 by 2, 1 by 2 will be, 2, 2 will be cancelled. 1 minus 1, 0. This term will be vanish. So finally, you'll get ui comma j equivalent to 1 by 2 ui minus 1 comma j plus ui plus 1 comma j. This term only you'll get. This is the uh, simplest form, reduced form of the Bender-Schmidt recurrence equation. This is going to call, this is explicit formula. Equation 2, previous one is explicit formula. Equation 3 is Bender-Schmidt recurrence equation. Here, if you are giving lambda equal to 1 by 2, in that formula, what is lambda formula? Lambda value k by ah square. So lambda equal to k by ah square. I'll replace lambda by 1 by 2 is equal to k by a into h square. Then what about k value? A into h square divided by 2. So this will be important on here. Using this one only, we have to find the step size in the t direction. Right. K equal to ah square by 2. Suppose here lambda equal to 1 by 2, then k is ah square by 2. I'm going to give the diagrammatic representation for that. This is the formula, Bender-Schmidt recurrence equation for the particular value of lambda equal to 1 by 2. So the diagrammatic representation. So I'm going to take x-axis in that direction, positive t-axis in that direction. Always we will draw the graph like that only, x t, but for our convenience, I'm going to take like that. This is x direction, and the downward, this direction will be positive t direction. So if it is like that, well, I'm finding, if you want to find this value, d value, then average of a plus b by 2. So you can no need to memorize this formula. In MCQ purpose, for MCQ purpose only, they will ask to solve the problems. You no need to remember that the diagrammatic representation is more than enough. So then d is equivalent to 1 by 2 of a plus b, average of, if you want to find this value, uh, right side top corner, left side top corner divided by 2. This side also position value will be here. Right top position, left top position by 2, average of the two values. That's it. This is a diagrammatic representation for Bender-Schmidt method, guys. Okay, that d equivalent to I have given here. D equivalent to 1 by 2 of value of a, value at a and plus value at b. Right. Now suppose if lambda equal to 1, lambda equal to 1, it is not valid. Am I right? It won't converge. Sometimes there is a possibility they may have such kind of problems also. If they're asking, be ready to answer for that. If lambda equal to 1, if you're giving in the explicit formula, you will get this one only, equation 2. The diagrammatic representation for equation 2 will be this. So here it is not average of 3. If you want to find the value of D, the value of A plus value of C, A plus C minus B. We have to add here, we have to subtract here. Minus b. Clear? A plus c minus b. This is what the formula if we are getting lambda equal to 1. That's it, guys. Now I will explain with an example, then only easily you can understand the concept. How to identify it is under which kind. Particularly, they will mention because as I told you already, in Laplace equation, two methods are there. One is Bender-Schmidt, what we are discussing now. Another one is Crank-Nicholson. I will we can see in the another video. The topic will be there. So if they did not mention anything, you can use any one of the method. Maximum they will mention. If it is here, it is not there, but in examination they will mention. If it is not there, you can use it, which is easier for you. You can use that concept, right? How to identify? It is one-dimensional theta. In the beginning itself, not in this video, in the previous first video of this topic, I have given the clue how to identify. It is heat equation, wave equation, and the Laplace equation, everything. So heat equation is second derivative of u with respect to x, and the one first derivative with respect to t will give heat equation. So this is the heat equation, and they have given the boundary condition 0 comma t 0, 4 comma t 0, and initial condition is u of x comma 0 equivalent to x into 4 minus x. And they have given the value of h. Find the values of u up to t equal to 5. Up to the time. Time is 5 seconds. They have given t equal to 5. Clear? Right. Now, what are the things we have to choose here? From the given question, I asked to write like that u double x equivalent to 2 into ut. Just write it first like that, then only you can choose a value, a equivalent to 2. And what they have given, h is equivalent to 1. Using this, we have to find the value of k. It is a h square by 2, which is equivalent to what is a value 2? What is h? 1 whole square divided by 2. And what about k value? 1. So from the given equation, you have to write a, check whether they have given h or not, or you have to assume. So h equal to 1 they have given using both. So guys, if you are doing any mistake to find the value of a, it will be negative or some other thing, the entire problem will be wrong. Take utmost care before to solve it. In this method and the Crank-Nicholson and the upcoming methods, you have to choose your value of a very carefully. That's why I asked to write both and both the derivatives are extremely other side. Do not write together to the left hand side like what they have given here. Will confuse whether the a value is minus 2 or 2. So take to the right hand side. One derivative should be left hand side, one derivative should be in the right hand side. So the t coefficient, ut coefficient is e. Am I right? Right. So this is the value of finding the value of k. Right. Look at that. U double x equivalent to 2 into ut, a equal to 1, h equal to 1. In Bender-Smith method, k equal to a h square by 2. So k value also 1. So what is the meaning for that? I am going to find this is my what is the direction? This is my x direction. This is my t direction. In x direction difference is h. T direction difference is k. That means what? H equal to 1 there. Okay. K equal to 1 we found just now. So if you know that one only, we can find the solution. Right. So k value we found. K equal to 1 now in t direction, that is step size in t direction. H means step size in the x direction. That's it. Now come to the problem. We have to find the table values, boundary conditions, these two, and the initial condition, this one only. Right. I'm going to draw the line. This is x direction. This one is x direction. And this one is t direction. Look at that I have given. X direction, h is equivalent to 1. T direction, k is equivalent to 1. Right. What about in where it's varying from 0 to 4? X varying from 0 to 4. 0, 1, 2, 3, 4. because h difference in x direction is 1. So starting from 0, x is varying from 0 to 4. 0, 1, 2, 3, 4. And what about t direction? T direction, it's going to vary k equal to 1. T starting from 0 only. So 0, 1, it will be more like 2, 3, 4, 5. Up to 5 seconds they asked to find. That's it. Is it clear, guys? For your understanding purpose only, I have given the different colors. This color represents this color represents one boundary condition. This color represents another boundary condition, and this color represents the third boundary condition. I mean, two boundary condition, one initial condition will be there. All the three boundary conditions are in this box only. What about the rest of the thing here? These are all the interior points, whatever we are going to find. This one only we are going to find. Apart from everything are there using the given boundary and the initial condition, we have to write it. The interior, this values only we have to do. This is a rod. One-dimensional heat equation means it's a rod. Boundary condition is there. We have to find the temperature distribution in the rod, resulting temperature distribution in the rod. That's what we are going to do here. Right. Now, just listen. I'm going to uh, take one boundary condition. What is the boundary condition? U of 0 comma t equal to 0. Where I have to mark either this or this or this. Where I have to mark, any idea? X equal to 0. Where is x equal to 0? In another axis, t axis, confirmly this position. So u of 0 comma t equal to 0. What it represents for all values of t. If t is whatever it may be, then u value will be 0. 0, 0, 0, 0, 0, 0. Clear? Similarly, what about other boundary condition? U of 4 comma t equal to 0, x equal to 4, where it will be this one. So u of 4 comma t equal to 0. Whatever it may be t, for all t, this value will be 0. So 0, 0, 0, 0, 0, 0. What is the last boundary condition? U of x comma 0 equal to x into 4 minus x. T value 0. T value 0 where it will be in the x-axis. This is what x-axis. X direction. This is t direction. So t value 0 will be in the x direction. That is this line. This line represents u of x comma 0 equal to x into 4 minus x. Right. Now give x value 1. What will happen? 1 into 4 minus, sorry, x value 0 first. X value 0, it will be 0. As I told you already, the corner value should coincide 0. X equal to 1, give x equal to 1, 1 into 4 minus 1, it is 3. Give x equal to 2, 2 into 4 minus 2, 2, it will be 4. Give x equal to 3, it will be 1. Give x equal to 4, x equal to 3 means it will be 3. Give x equal to 4, 4 minus 4, 0. So this value will coincide the corner values. That's it, guys. So in next direction, difference we have written with the help of the given one. T direction, k value we found, we have written the distance, I mean step size, and all the three boundary and the initial conditions we have completed. Is it clear? Right. Now we have to find the interior values. Resolution. So first boundary condition 0, 0, 0. Next boundary condition 0, 0, 0. Third boundary condition will be this. It will be this u of x comma 0. It is going to get placed here. It will be here. 3. That way, x value 1, 1, 2, 3, 0, 1, 2, 3, 4. You have to give here. 3, 4, 3. The boundary value should coincide here. That's it. We found everything. Now we have to find this value. This value I have to find. How to find? Any idea? Bender-Schmidt method. What is the diagrammatic representation? Left side most top value, right side one value, the right side top most value. Average of this two. 0 plus 4 by 2, it is 2. Similarly, what about this position value? This plus this divided by 2. 3 plus 3, 6 divided by 2, it will be 3. What about this position? This plus this divided by 2. That will be 4 plus 0 by 2, it will be 2. Clear? That's it. 2, 3, 2. Now next I have to find this value. What will be 0 plus 3 by 2. It is 1.5. Next step. 2 plus 2 divided by 2. It will be 2 only. Next step. 3 plus 0 by 2 will be 1.5. Similarly, proceed like that. 0 plus 2 by 2. It is 1. 1.5 plus 1.5 divided by 2. It is again 1.5. 2 plus 0 divided by 2. It is 1. Again 0 plus 1.5 divided by 2. 0.75. 1 plus 1 divided by 2. 1. 1.5 plus 1.5 divided by 2. It is 1.5 plus 0 divided by 2. 0.75. Similarly, proceed for the other value. That's it.